There are few approaches to making gasket. Usually we are taking that metal. You can make a round, you can make any shape you like. I will show you simple approach. Let's make round.
So the shape of gasket is not that much.
No, absolutely no matter.
I thought it should be very precise.
No matter. For this cell, has no matter what you're doing. Just the gasket by itself is important, but how you make that gasket is absolutely not important.
And is that steel?
That is steel. It's the same steel I was showing. I have shown it to you. Yeah. But it's no matter, it's round, flat,
Or rectangular?
rectangular. What I'm usually doing for this ground, I'm making 2 cuts on each side. No matter where. Just technological.
Can see that. Okay, whenever you want to go.
Okay, fine. So what I'm doing, I'm making balls after of that. Not too big, not too small. Usually 2 is enough, but you can put 4 of them. It's not a big deal. More stable.
No, thank you.
Okay. Now, let's tell you have mark here. You must make same mark on your gasket. You drop your gasket into that place.
Mhm.
It's too much. Too much. Mark. Those holes are technological holes, just to
Oh,
hold,
that's because of that.
to grab gasket. That's it. Goes there, push down to the diamond. Now next operation. Close gasket. Now you can apply force. And now you have a left-handed and right-handed.
Don't you need to align it again, or
No, everything is already aligned. All the trick is that everything is already aligned. Left-handed, right-handed. Those are right-handed. Here's your box. Close. Left-handed. Close. That is again left-handed. Close. Right-handed. Close. Now we must do indentation. What is indentation? It's the making a hole. Making that gasket much thinner. So what usually, because I know the thickness is original thickness of the material, 330, that is very thick. 330 micron.
330.
330 micron. So it means when during indentation, if we want to have final thickness like 70 micron, we must make a movement like 250.
That hole is to make that inside that.
The idea is initially it looks like that. It's an initial position. You have a one anvil, second anvil. The final product must look like diamond. Other diamond. That is indentation. Thickness of this indentation must be something like 50 micron. That is indentation. That is called indentation.
And how can we do that?
So we have now 330. Yes. We want to have 500. So 50 micron. Substrate for 330, 50 micron,
200.
270 micron. So we must make movement 270 micron. How we are doing it? Usually, it's my technique, but you can develop your own. I'm doing like that, taking the caliber, zero it in certain position. Okay, zero. And then I keep rotating, but again we have a left-handed and right-handed. So those are left-handed. You have to turn them this way. This way. And that is right-handed. We are turning it here, that way. How you are doing, usually you need to do one turn, half turn, or one turn. I'm starting with one turn. Same here. One turn. One turn. Again here. Make a, let's tell, half turn. Half turn. Half turn. Half turn. Half turn. Let's measure now there. It's already 0.3 micron movement. I believe it's already might be indented. Because it's small diamond. You have small. The same. Don't do sudden movement.
You want to increase this amount to 270?
Yeah, it was already bigger number. I will see. I'm not. I don't have feeling too much with this cell, so it's a rough estimation. We did 330. So let's see what we will get out of it. Okay, we have indentation there. See? Small hole?
Yes, I saw that, but here it cannot.
You can look on the microscope and see how it looks like. Don't turn here, turn only by this last knob. .36 micron. It's thinner than it must be, but it's fine. For first run, no matter. 36.
It should be between 50 to 70.
It's too thin. Actually, we can make a new one. It's not a big deal. It means I make it 1.5 turn was too much for this cell, for this configuration. It means it's too hard, that cell. Or it's too I'm not used to work with such small diameter of the cullet. It's because of small diameter of the cullet, the small turn make a higher pressure. It's already damaged.
Oh, it's there.
I see, but doesn't make a nice. Doesn't make a nice. Oh. Drop. Again, in your place, you will have more time to play. Maybe we have to switch change the configuration of those springs to make it less stiff. So, but right now, let's don't change. Go to
Now it's 4x4.
4x4. We can make a 3x3, for example. Then it will be more flexible. What was 330? We make 330 we get in this reading. So that for our thickness became something like that. Because that number it's not real number. It's just movement of the because there are other mechanical things which are going on inside. Okay. Same operation. Zero. Sorry, I just make zero in this in this position. That's zero. And now I'm making first half turn. I will not make full turn. I make half turn. Half turn. Half turn. Half turn. Half turn. Again I'm measuring. Almost no change. Right now. Like again. Half turn. Half turn. Half turn. Half turn. Measure it again. 0.2. I need to do it a bit more. Make water. 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 0.28. Might be good. No. But you get what I am doing right now. It's a movement of the one part against other part, which corresponds mostly for indentation, deformation of that metal. Other technique of indentation is to put piece of ruby under the diamond
And
right on the metal and keep squeezing till your final designated pressure. Observe of my scale. In this moment, I believe that electrode and lens are looking into the same position. Yes,
right now it's the hole is at the center of
of the optical system. So it means optic and mechanics are
both of them are in
all
same place.
So now I can easily bring my actual gasket into the same place, and by looking to the optical system, hope that mechanics will come to the same place. What I am doing, I will do it like that. So I will just now I not supposed to touch that lens. Thing. Now I'm touching only station. So I'm bringing my station, and here is that indentation. I am putting indentation into the center of my optical system.
But you have done it. You already done it. Why do you changing it?
No, because I did some random hole outside. Now I want to make hole right in our indentation.
The previous one is that hole.
The previous was just hole made by
Your test hole.
Test hole. Now I will make a real hole in the designated in the place I want to have hole. So now it's in the center.
اون کالیبریشنش بود که ببینی اون جایی که نگاه میکنی همون جایی که دریل میکنی یا نه.
آها.
بعد که تنظیمش کردی مطمئن شدی حالا اون جایی که نگاه میکنی همون جایی که دریل میشه میبریش وسط ایندنتیشن که حالا وسط اون دریل.
Again, I am feeling everything by this liquid. Turning in again. Bringing it till I have a light on. In this moment, I have a micrometer here. I can set a micrometer indicator in order to it's 0, so I have the thickness of 50 micron. It means it's here. It means when indicator will be in this position, it will indicate that we have hole through.
But now it's not in 50.
No matter, it's some relative position. It's just position in which moment I am touching to the surface. So I'm touching to surface in this position. Doesn't matter where it's 0. Important is difference. Because that indicator doesn't measure real thickness. It just show me what is the position of the station. It just so the other indicator will be here, but I don't have to. So it's just for my information. It doesn't give any command to machine. It's just for us to know that okay, it's already we are close to. It's actually don't have to set second one. It's enough to set first one and know when it will be there. It is done. So now machine is starting to drill. I should set a little bit lower voltage. Your machine works very similar way. It means all the processes which are going on are the same, but the mechanics is a little bit different on your machine.